Have you ever wondered how your kidneys filter your blood? Or how plants take water in through their roots? Well, the answer is osmosis, the diffusion of water molecules across a semi-permeable membrane from an area of high concentration to an area of low concentration. A good way to illustrate this process is through naked eggs. To make a naked egg, we had to dissolve the shell in vinegar, also known as acetic acid. The vinegar reacts with the calcium in the eggshell, thus dissolving it. We first poured vinegar into a jar, and then we placed an egg into it. At first, there were very few bubbles that formed around the egg. Yet 15 minutes later, there were many more bubbles. Now the chemical reaction of the eggshell and the vinegar creates carbon dioxide, which are the bubbles that form around the egg.
After leaving the eggs in the vinegar for 24 hours, the shell is completely dissolved and we can begin our demonstration. We took 2 mason jars, corn syrup, and water. The eggs will act as cells in this demo. The corn syrup will be our hypertonic solution, or a solution with a greater amount of solutes outside the cell than inside of it. The water will act as a hypotonic solution, a solution in which the concentration of solutes is greater inside the cell than outside of it. Since the corn syrup is a hypertonic solution, there will be a net movement of water outside of the cell, or in this case, the egg. As you can see, the shell of the egg is completely gone, leaving nothing but a squishy, translucent egg membrane. But again, for our purposes, it's acting as a cell membrane. The next step is to cover the egg completely in corn syrup, our hypertonic solution in this demonstration. And voila! You end up with an egg floating around in a bunch of corn syrup. Up next is the water. Since it's a hypotonic solution, there will be a net movement of water into the egg through the egg membrane. By the way, the white bowl you see here is simply there to rinse off the remaining dissolved shell from the egg. It serves no special purpose. And there we go. 1 egg is in a hypertonic solution, and 1 egg is in a hypotonic solution. Now we let them sit for 24 hours and see what happens.
Now, how does this all work? Well, this works on the principles of diffusion, which is the movement of molecules across a semi-permeable membrane. Most polar molecules, such as sugar, cannot pass through this membrane. However, water molecules can cross this membrane, and this is called osmosis. Now, let's say another molecule, such as urea, is added to the solution of water. It won't diffuse because it is too large. However, since it's polar, it will interact with the other water molecules, thus lowering the number of free water molecules on the right-hand side. Thus, there is now a net movement of water across membranes to the right until it becomes isotonic.
Or, in other words, where the concentration of solutes is the same on both sides of the membrane. Now knowing exactly how osmosis works, can you predict what happened to the eggs? The egg that was in the corn syrup noticeably shrunk, leaving the membrane loose and saggy. The egg in the water, on the other hand, became much bigger. Also, side note, we had to move the egg to a different jar of water to give it room to swell. Here, you can see the amount of water the egg absorbed compared to the egg weight. What we ended up with was 1 very shrunken egg and 1 very swollen egg. So we know how osmosis works, but why exactly is it that water moves in and out of the cell, or in our demonstration, the egg? In 2003, scientists learned that the water channel in the semi-permeable membrane of a cell is positively charged in the middle. Thus, it deflects other positively charged ions and allows only water in and out of the cell. So that's the end of our demonstration. But just so you guys don't think osmosis is completely useless, here are some real-life applications. There's an emerging method of preserving and drying fruit called osmotic dehydration. The process is relatively simple and involves merely removing the water from the fruit by soaking it in an osmotic concentration, or as we know it, a hypertonic solution. Thus, there's a net movement of water from inside the fruit out into the hypertonic solution, causing the fruit to become dehydrated. This process is said to preserve more of the fruit's natural nutrients, and is beginning to be used with all kinds of fruits such as bananas, papayas, raisins, and apricots. Another very common instance of osmosis is in pruny fingers, something we've all experienced. However, contrary to popular belief, your fingers aren't shrinking, they're actually expanding. This is the very basis of osmosis. The water in the pool or a bathtub is a hypotonic solution, so it's trying to get to equilibrium by moving into the cells in your fingers and toes, thus making them pruny.